Hello, my dear students. Welcome to Gurukul Academy. Today, in my video, I'm going to show you how to draw the Lewis dot structures for the carbon monoxide molecule, the nitrite ion, ozone molecule, nitrogen trifluoride, carbonate ion, and HNO3, that is nitric acid. First, let us know the significance of writing and drawing the Lewis dot structures. The Lewis dot structures provide a picture of bonding in molecules and ions in terms of the shared pair of electrons and the octet rule. So first, let us see how we can draw the Lewis dot structures for carbon monoxide molecule. So I'm writing the formula carbon monoxide. So let us first count the total number of valence electrons. Valence electrons for carbon 4. Valence electrons for oxygen is 6. Now I am going to add valence electrons of both carbon and oxygen. So that is 10 electrons. Now we have to distribute the 10 electrons between carbon and oxygen. So first let us draw the basic skeletal structure. Now between carbon and oxygen, I am going to draw a single bond by sharing a pair of electrons. And the next step would be complete the octet over oxygen. 1, 2, 3, 4, 5, 6. Now let us count the total number of electrons distributed. 1, 2, 3, 4, 5, 6, 7, 8. So the remaining two electrons would belong to carbon. Now let us check whether each of the two atoms satisfies the octet rule or not. For oxygen, yes, but for carbon, no, it doesn't. So now, how to solve the problem? We have to resort to multiple bonding. So how can we do it? We can accomplish this by shifting a pair of electrons from oxygen and this pair of electrons also from oxygen and involve them in chemical bonding. So now let us redraw the Lewis structure. So now there would be 3 pairs of shared electrons. Only 2 are remaining now here and the other 2 here. Now let us check whether both carbon and oxygen are satisfying the octet or not. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now for oxygen, it is satisfied. How about for carbon? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So now, as per the rules, both the atoms should satisfy the octet. So carbon is able to satisfy the octet. Oxygen also is able to satisfy the octet. Now let us draw the Lewis structure. There is a lone pair of electrons on oxygen and a lone pair of electrons on carbon. So this is the structure for carbon monoxide. Hope you have understood the concept very clearly and hope the video is good. Thank you very much. Hello, my dear students. Now next, let us proceed to drawing the structure of the nitrite ion, NO2 minus. First, let us count the valence electrons for nitrogen and oxygen. The number of valence electrons for nitrogen are 5. The number of valence electrons for oxygen, because here 2 atoms are involved, so 2 into 6, that would be 12 electrons. And since this is a negative ion, since this is an anion, so we have to add 1 electron, because anions are formed due to the gaining of electrons. So hence I am adding 1 electron to the total number of valence electrons. So that would be 12 plus 5 plus 1, that is total is 18 electrons. So now let us distribute the 18 electrons between nitrogen and oxygen, and let us try and draw the Lewis structure for the nitrite ion. So first, let us write the basic skeletal structure. Now, since as per the rule, the least electronegative atom should occupy the center of the ion or the center of the molecule. So since this is a polyatomic ion, between nitrogen and oxygen, nitrogen is the least electronegative. So I am writing the basic skeletal structure by putting nitrogen in the middle and oxygen one on either side. Now first, let us draw a single bond between nitrogen and oxygen by sharing a pair of electrons on this side and also on this side. Now let us complete the octet over each of the 2 oxygen atoms. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, let us count the total number of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, we need to put the remaining 2 electrons over nitrogen. And now let us check whether the octet is satisfied or not. 1, 2, 3, 4, 5, 6, 7, 8. Yes, for oxygen it does so. 1, 2, 3, 4, 5, 6, 7, 8. Yes, for the other oxygen also it does so. But how about for nitrogen? 1, 2, 3, 4, 5, 6. No, it doesn't. So how to solve the problem? Again, we have to resort to multiple bonding. Now, we can shift a pair of electrons from either of the 2 oxygens. So, I am shifting a pair of electrons from this oxygen towards a double bond here. I can as well shift a pair of electrons from this oxygen also towards this bond. Then there would be a double bond between nitrogen and oxygen. Here, since I have shifted a pair of electrons from this oxygen towards the formation of a double bond, there would be a double bond between this oxygen and nitrogen. Now, let us redraw the Lewis dot structure first. Three, 4, 5, 6, 7, 8. Now here there are 2 shared pairs of electrons. 1, 2, 3, 4, 5, 6, 7, 8. The other 2 would be the lone pair over nitrogen. Now let us check whether each of the 3 atoms is able to satisfy the octet rule. 1, 2, 3, 4, 5, 6, 7, 8. Yes. For this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now over nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Yes. So hence we have seen that all the three atoms are able to satisfy the octet rule. Now let us draw the structure. There would be a double bond between this oxygen and nitrogen, with a lone pair of electrons over nitrogen, two lone pairs over this oxygen, and three lone pairs over this oxygen. And I am going to include it in a bracket with a negative sign since this is an ion. So this completes the structure of the nitrite ion. I hope the video is very clear to you and the video is good. Thank you very much. Hello my dear students, welcome back. Now let us see how we can draw the structure of the carbonate ion, the Lewis dot structure for the carbonate ion. Let us first count the number of valence electrons for carbon, that is 4 valence electrons. For oxygen, it would be 6 into 3 since 3 atoms are being involved. 6 into 3, that would be 18 electrons. And I'm going to add 2 electrons because this is a polyatomic ion and it carries an overall charge of -2. So I have to add 2 electrons. So that would be 18 plus 4 plus 2, that is 24 electrons. Now let us see how these 24 electrons can be distributed between carbon and oxygen atom. So first I have drawn the basic skeletal structure. So as per the rules, carbon is the least electronegative and that should occupy the center of the polyatomic ion. So carbon is in the center with 3 oxygens on the sides. And first I have drawn single bond between each of the 3 carbon oxygen bonds. So this is carbon oxygen single bond. There is a single pair of electrons here. Again, there is a carbon oxygen single bond. Again, there is a single pair of electrons here. And there is a carbon oxygen single bond. Again, there is a single pair of electrons here. And then complete the octet over oxygen. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8. So the octet over oxygen is completed. And we have to check whether all the 4 atoms are able to satisfy the octet or not. For oxygen, yes. For this oxygen, yes. For this oxygen also, yes. But how about for carbon? 1, 2, 3, 4, 5, 6. Only 6 electrons for carbon. So what we see is for carbon, the octet is not satisfied. So how to solve the problem? We have to resort to multiple bonding between carbon and any one of the 3 oxygens. So I can shift a pair of electrons from this oxygen to this bond, or I can shift a pair of electrons from this oxygen to this bond, or I can shift a pair of electrons from this oxygen to this bond. And that would lead to resonance structures. So here what I'm doing is I'm shifting a pair of electrons from this oxygen so that there is a double bond formed between this oxygen and carbon. So let us redraw the Lewis dot structure again. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now since I've shifted a pair of electrons here, there would be a double bond here. So there would be 2 pairs of shared electrons, leaving with the remaining electrons this way. Now let us check whether the octet is satisfied now or not. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Yes. For carbon also. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So now what we see is the octet is satisfied over all the 4 atoms. Now let us draw the structure of the carbon. Let us draw the structure for the carbonate ion. Now remember, there is a double bond here. Now let us draw the lone pairs. 2 lone pairs here, 3 lone pairs here, and 3 lone pairs here. And I'm going to include the entire structure in a bracket with a charge. So, my dear students, this is the structure of carbonate ion. This is the Lewis dot structure of carbonate ion. I hope the video is clear to you and the video is good. Thank you very much.